If you haven't been living under a rock for the past 3 or 4 years, I'm sure that you have seen these really cool looking Raspberry Pi clusters on YouTube. You can see these tiny computers stacked together in little towers, and once you start going through this rabbit hole, you will start seeing lots of different options stacked in a really neat way, looking really cool. You can see, like in this example, tens of different Raspberry Pis stacked in this way, or perhaps stacked in this way, where they are just using compute modules instead of the whole Raspberry Pis. And there's always this little voice saying, yes, but these are tiny computers, they are toy computers. There's no actual use that you can give to these things. So in this video, I'm going to show you why you do actually need to have your own Raspberry Pi cluster, why it is something really useful, not only for sharpening your engineering skills, but also to be a way for you to generate multiple revenue streams that you can rely on monthly basis. If you don't know me, my name is Fede. I'm a software architect with more than 15 years of experience working in production systems. I worked with multiple companies across the world, solving a wide variety of problems. Now, let's start from the very beginning. What is a cluster? Why are people building these things? So a cluster is basically a group of interconnected devices that work together as a single system in order to do something. What we want from a cluster, and one of the main reasons why we build a cluster, is to improve performance, availability, and scalability. Since in this case we are talking about a Raspberry Pi cluster, we are obviously going to use a Raspberry Pi. In case you don't know what a Raspberry Pi is, there are thousands of videos in YouTube about these little devices. In a nutshell, they are tiny computers, but don't let the size fool you. They provide a fully functional machine that it fits the palm of your hand. It has a processor, RAM, USB ports, Ethernet, HDMI output, and also GPIO pins that you can use to expand the capabilities of a Raspberry Pi. What makes them so good? They are cheap, really low powered, silent, and incredibly versatile. That's why they are the perfect choice to build these kind of clusters. In the case of a Raspberry Pi 5, you have a quad-core CPU. You also have different sizes of memory that you can pick. One of the cool things about the Raspberry Pi is that comes with these GPIO pins that you can see right here, and it allows you to expand the capabilities of the Raspberry Pi. You can add different hats, so you can add a PoE hat or an NVMe HAT or an AI HAT, different boards that you can use to expand the capabilities of the Raspberry Pi. Now, suppose for a moment that you are working with a given application that you are developing, right? Suppose that you are developing a REST API or a gRPC API or a front end to solve a specific problem. So now that you have the application, one thing that you can do is deploy the application on this tiny computer and make that application available to the world. You can expose this application using your home network, so you can make it available to anyone outside of your house. Once you install the application in this Raspberry Pi, now you realize that you need a database. So one thing that you can do is add a new Raspberry Pi and install the database in this new device. So you have your application running on this computer and you have your database running on this computer. The moment you do that, you might think, what if this Raspberry Pi dies, right? So you will lose your whole database. So you can add a new one and replicate your database across these two different computers, so now you have redundancy. If one of these computers goes down, you still have the other one, giving you the redundancy that you will expect from a database. Now that you have done that, you have redundancy for your database, but you still don't have redundancy for your application. So you can add a new Raspberry Pi and install the database on the other two. So now you have redundancy for both your application and for your database. And that's exactly why we need a cluster, because now, as you can see, we can group all of these computers into a single cluster, and instead of accessing each of them individually, one thing that we can do is add a single entry point from here. So now, instead of accessing each of the Raspberry Pis individually, we are going to access the cluster using a single entry point here, and we can load balance the traffic depending on what we want to do. If we are receiving a database operation, then we go to the database. if we are receiving a gRPC request or an HTTP request, we go to the computers holding the application. And as you can see, this whole cluster acts as a single unit, providing a solution to a specific problem. This is exactly what you get when you deploy your application on Google Cloud or AWS or Azure. Whenever you are using a cloud provider, what you are doing under the hood is implementing these exact same features. You want your applications to scale based on the traffic. You want high availability, meaning that your applications will be running 24/7 without any problems. And you want redundancy in case something fails, your application still works. So let's recap. What do we want out of our cluster? We want to improve performance. We want to ensure that our cluster allows us to improve the performance of our services by relying on the different nodes that we are going to include as part of our cluster. We want to ensure the availability of the applications that we are deploying in there. We want to make sure that these applications are always available every time we need them. We want to ensure the scalability, so we are able to scale our cluster based on our needs. We want to ensure that our applications can scale in order to process all the requests that we are having. And also we want to have redundancy, meaning that if any of the parts of our cluster fails, our applications keep running exactly as we want them. Now, with this in mind, let's review some of the clusters that you will find once you start going through this rabbit hole. In this example, you can see 5 different Raspberry Pis stacked in this way. So they look really neat, they look amazing. And the really good thing about this is that you can take your whole cluster and move it around whatever you need the cluster to be. Here we have another example doing the exact same thing, stacking the Raspberry Pis one on top of the other, giving them the ability to add more Raspberry Pis whenever they need. And you can see that in here they have plugged in only 3. This one is not working at the moment. And as you can see, you can have them as different modules, enabling or disabling them based on your needs. Remember that one of the key features that we wanted to have out of our Raspberry Pi cluster is redundancy. And that's aiming to always have a backup plan. If something fails, if any of the devices that we have in our cluster dies for some reason, we want to ensure that everything within our cluster keeps working as expected, allowing us to work on that problem without affecting the behavior of the whole cluster. Now, suppose for a moment that for some reason, this Raspberry Pi that we have right here dies. Whatever will happen with this specific Raspberry Pi, but for some reason this device here goes down. Or even worse, this device here gets on fire. Now think for a moment what will happen in this case if you need to replace this specific Raspberry Pi, this specific device. You will need to take the whole thing apart, you will need to disassemble the whole cluster in order to replace this single device. And that specific thing, if you think about it, goes against everything that we have been talking so far about redundancy, scalability, performance, because if this device breaks, or even worse, if it gets on fire, it will affect all the other devices in the cluster at the very same time. So on one hand, yes, these clusters look amazing, but they all have the same problem. We have this other example here. This is an amazing cluster that you can find on YouTube. I will put the link to this video down below in the description. But one of the things that creeps the hell out of me is this specific problem multiplied by 10 times. You can see in here they have 32 different Raspberry Pis stacked in this way. So suppose that this one in here dies, or this one in here gets on fire. This entire thing is depending on each of these Raspberry Pis, and there's no way for you to replace one of these without affecting the behavior of all the other elements in your cluster. If you need to replace this specific Raspberry Pi right here, you need to disassemble this whole tower, remove all the screws and bolts that you have in here just to replace this little device right here. Here you have different compute modules that are the compute part of the Raspberry Pi, but without all the GPIO and all the I/O features that you will get from a regular Raspberry Pi. They don't have USB, they don't have RJ45 connectors, they don't have the GPIO pins, but they provide all the computing power that you will get from a Raspberry Pi. And you can install these compute modules in this board, allowing you to have 6 or 12 different compute modules working together as a single cluster. But you can see that in here, it is even worse. What if this specific component fails? Or what if your network interface fails? You have one single network interface right here. You have one single processor in order to coordinate all these different compute modules. And that, again, is going against everything that we want out of a cluster. You have the exact same situation happening in here. You can see that we have 4 different compute modules. In this case, each of them is having its very own heatsink over here. But again, you have a single point of failure. You have a single board managing and coordinating all these different compute modules. But if this component right here fails, the whole thing goes down. And that's the kind of thinking that we need to have every time we are designing something. Even more important, in software engineering, we always want to have a plan B. We always want to think what's going to happen with our system if one of the components of our system fails. Now, we have covered what a cluster is. We have reviewed the different clusters that you can find on the internet whenever you want to go down this rabbit hole that is owning your own cluster. Now let's review why you actually need your own cluster and why it is such a good idea for you to have your own cluster. First of all, and to me this is the most important point that I really want to share with everyone that is looking at this video, and if you are going to take something out of this video, let it be this: validate business ideas. I have talked with hundreds of different engineers during my whole career, and regardless of where they were working at or what they were doing, they all had these fantastic business ideas that they wanted to execute. Now, every time you have an idea that is solving a specific problem by implementing a specific solution, you will always require some common things. You will always require authenticating users, creating those users, creating session tokens, creating JWTs, deploying different services, interacting with different databases. Once you have a database, you need to back up that database on hourly, weekly, monthly, daily basis. Take, for example, what you are doing right now. Perhaps you are working for a company or you have your own company. I don't care, but I'm sure that you are using technology to solve a specific problem. Now, in order to do that, you need to have users or you need to have people using your applications, and that people must be able to register to your application, use your application, interact with any kind of front end or mobile application or whatever in order to do something. So those are common aspects that you will find in every company in the world. If you have a cluster that already allows you to register new users, to create new users, to deploy new services, to expose those services or expose those front ends or APIs or whatever you are developing, you already have 90% of the problem solved. You can focus on building the actual solution to the problem instead of focusing on the technology side. The fact that you have your own cluster gives you the chance to do that from day one. Let me give you one example. In here where I live, we don't have that quality drinking water that you will get from big cities. You can drink the water, but it is a really heavy water with lots of minerals. So people are buying drinking water from local suppliers. So I have this guy coming to my house every Tuesday and he's delivering drinking water. He's doing this by using a notebook where he writes down all the different customers that he needs to visit every day. And in that notebook, he's putting the address of the customer, the current debt of that customer, how many bottles of water that customer still needs to pay. And every time he goes to visit each specific customer for every weekday, he's writing down in those notebooks the current status of each of the customers. So we were talking one day on the street, and when he mentioned that, I said, that's a problem that I could probably solve really quick. So what I did is I created this small Android application allowing him to register the different customers. He can pick the customer geolocation on a map in the Android application, and he can define the visit days for each of the customers. Now, what this application is doing under the hood, every day it is calculating the route for the next day, putting all the customers in the correct order, optimizing how he should visit each of the customers based not only on the visit days for each of the customers, but also based on the time when that customer wants to be visited. With this application, he just follows the route and goes to each of the customers that he needs to visit every day. Every time he arrives to each of the customers, the application itself is finding the closest customers using geolocation, and he can see the status of the customer, the current debt, how many pending orders, and the amount of money that that customer needs to pay. He can create a new order, deliver new products, and track this whole business using this simple Android application. Now, this application is communicating with the backend using gRPC endpoints, gRPC APIs, and all of these APIs were implemented on different Go services deployed in my local Raspberry Pi cluster. Now, the really good thing about this is that since I already had all this infrastructure ready for me to use, I only had to work on the specific services to implement each of these requirements and then deploy those applications to the cluster. We both had the chance to validate that what I did actually solved the problem that he was having. I eventually took all this cluster configuration and moved that to a cloud implementation. But I had the chance to use my cluster to validate my business idea and confirm that I had customers, paying customers, on the other hand, willing to use my product in exchange of a monthly fee. So this is the most important aspect of having and owning your own cluster, is you can use it to validate that the idea that you have is actually valuable to someone, and you can charge money for that instead of spending months and months of development in something that no one is going to use. As you can guess by now, I did all of this by using Kubernetes. One really cool thing that you are going to learn when you have your own cluster is Kubernetes itself, how to install Kubernetes, how to manage a cluster, deploy different applications, install different types of load balancers, install databases on Kubernetes, perform backups, daily operations, schedule jobs to execute whenever you want them, perform backups, learn how Kubernetes networks actually work, integrate TLS certificates, HTTPS, gRPC, HTTP, all of that gives you a ton of knowledge about how Kubernetes works, and the fact that you can do it on your own bare metal servers is giving you a lot of experience about Kubernetes itself. So whenever you are talking with someone during a job interview, or you are talking with someone that asks you about Kubernetes, you already know because you already have working products using that Kubernetes cluster. So you will get a ton of knowledge once you start doing this. So now you have created your Kubernetes cluster. Of course, you need to deploy different applications. Now in Kubernetes, you can deploy whatever the heck you want to deploy. So you will need to go through this cluster configuration and make sure that you can deploy different applications. If you're working with Go, Java, Node.js, React, I don't care. But you will need to deploy all of those applications to your cluster. And once you start doing this, you will have tons of different options. Are you using Helm, or will you use YAML files to manage your own cluster? You have a ton of options to deploy different applications, and here you will need to learn how to deploy those applications really fast and how to deploy new versions, how to execute blue-green deployments, how you roll back a deploy when something is not working. So that's giving you a lot of knowledge about managing your own cluster and the life cycle of the different applications that you deploy. Again, if you are deploying applications, at some point you will need to deploy databases. Now, whenever you start dealing with applications on your own bare metal servers, you need to start taking care of database synchronization, backups, daily backups, how you manage disaster recovery, what if one of the nodes is getting on fire, how long it takes you to get the whole cluster back online. So it is not only deploying and creating the database in the cluster, but also making sure that you can manage those databases in a proper way, so you are not losing data, you are always ensuring consistency, you will get a ton of knowledge, not only by installing the database, but also using those databases as well. As I mentioned, every time you install a database, you will need to deal with backup, recovery, disaster recovery. So this is giving you a ton of experience on real world situations. There's no difference between doing this within your own local cluster where you have your productive applications, or doing this for a company cluster in the cloud, in any cloud provider you want. The knowledge and the how-to is exactly the same, but in here you have the chance to do it yourself and to learn it yourself on your own cluster without risking company money. Of course, while you go through this whole process, you will learn a lot about networking, DevOps, CI/CD, reliability, scalability. You will be fighting against all these different requirements that you need to have in place in order to ensure that your cluster actually works. Configure remote DNS, configure TLS certificates, configure certificate renovations, issuing new certificates automatically, creating new subdomains automatically, how you create the different Docker images based on local development, how you deploy to the cluster automatically to staging environments without affecting the productive environments, how you read logs, because once you deploy the application in more than one pod, it is really annoying to look into each of the pod logs in order to find out what the heck's happening whenever you run the application. So naturally you will start going towards something like Prometheus, Grafana, Loki, whatever you are using to centralize those logs, how you get metrics from your application. If you are sleeping and for some reason MongoDB stopped working, or you are having a lot of lag in your database processing operations, you want to understand that in real time and you want to get an alert in real time. So you must have some tools in place to let you know that something within your cluster is not working. And as you can see, all of this is exactly what you are going to do whenever you go through a job interview. But in this way, you can get all this knowledge by just using your own cluster, developing and providing your own business ideas, in the meantime getting a paycheck by using these ideas. So you can see that whenever you want to work for a company, if that's something that you want to do, you already have all the knowledge that is required for you to have when you join that company. I have conducted hundreds of different interviews for different candidates for different companies in order to fill specific position within that company. And you can tell right away when someone has the experience, because they are talking as a pair. They are not just answering the question that I'm asking, but they are going through and they know what's coming next because they have done that. So for example, if I'm talking about deploying a database, they will start talking about data backup, recovery, or disaster recovery by themselves, because they know that it is not only deploying the database to the cluster, but also managing all the different situations that you will have after you deploy the database. Installing and configuring the database is just the first step. Once you have the database deployed, now you need to manage that database in a way that you can ensure you won't be losing any data, you will have synchronization in place, you will have some kind of eventual consistency at some point. So they are going through the interview not as an employee and not answering as an employee, but answering as an engineer pair, as a coworker. Whenever I see those profiles, I'm the first one raising my hands and saying, I want that guy on my team, because you already know they have what it takes in order to go through that position. And as you can see, it is really hard to get all of this knowledge from a specific company if you haven't done that on your own, because you will need to go through all these different things. And looking at this list, you can see that you have developer role over here, you have database admin or database engineer over here, you have DevOps or site reliability over here. So these are different roles filled by different people within a given organization, but having the chance to have this on your own will give you a ton of knowledge and a ton of experience. So whenever you are having your next job interview, you will be hordes of magnitude away of anyone that haven't done that what you already did. So finally, with all of this in mind, I'm going to show you the design that I came up with and how I went through every step of the process, and how I went through every step of the process in order to finally accomplish the cluster that I had in mind. First of all, make sure that I can use a standard 19-inch rack to keep everything organized and scalable. I also wanted to make sure that each component was fully modular from power to compute units, meaning that if any of the Raspberry Pis or any of the nodes that I have in my cluster goes down for whatever reason, I can swap that really easy without affecting the rest of the cluster. As you can see, meaning that I need to ensure that any part can be replaced without affecting the rest of the system, the rest of the cluster. Also, having independent management for each module. At the very beginning, I was using an unmanaged switch, so that was a painful experience. So I eventually upgraded everything to a managed switch, allowing me to enable or disable both the port and the PoE for each of the nodes that I have in my cluster. Then I wanted to ensure redundant power supply to protect against outages. Finally, I wanted to ensure that I have an internet backup that I can use to keep the cluster online at all times. Now at that moment I didn't have a network rack that I could use for this, but I did have all these little spare parts of metal in my backyard. So I decided to use all of these scrap pieces that I had lying around to build the whole rack. So in here is just making sure that I can clean all the different parts. After welding, just grinding all the different joints that I had to make sure that they were really smooth. After grinding, it's just putting a light coat of paint, 2 coats of paints actually, to the whole structure, putting the caps and the ends, making sure everything fits in the office. And here you can see that I had an RJ45 connector that I could use right next to the rack. This is how it looked at that moment. All these different units were built with the same material, that 40mm by 40mm steel tubes. I used the grinder to make those holes, making sure they were nice and neat. In here you can see the different Raspberry Pis being installed in their final holdings. At this moment I was using my home network, my old network, because I had a complete different router. Here you can see the switch that I was using, an 8-port switch. In here I already finished installing all the different Raspberry Pis and using the switch to power them all. After I went through that, I realized that I needed a new power distribution unit to ensure I was powering all the different devices connected to the rack. So I had to build this. Now I have 8 outlets in this power distribution unit, allowing me to connect much more devices instead of just having one plug in the wall. Here you can see the final desktop, how it looked. I had 2 racks of 12 units each, one on the left and one on the right, and the one in the middle is just for internal storage. And what you're seeing now on screen is the updated version that I did after a few months. I upgraded my home router to the UDM Pro from Unify. I also used the Unify switch, a 24-port PoE capable switch from Unify. There you can see the power distribution unit at the top as well, and the 8 different Raspberry Pis at the bottom. Behind the Raspberry Pis, you can see the Starlink router acting just as a modem. That's my alternative ISP that I have in here. And as you can see, this was a really neat setup at that moment. Cable management was a painful situation as well at that time. I ended up adding 2 cable organizers in there, a patch panel to support my video cameras, connection for the different access points, as well as improving the cable management for the different servers. I also ended up adding 2 more servers, not Raspberry Pis, different servers. I will talk about those in a future video. But as you can see, the final product looks amazing. Now I can manage each of the different Raspberry Pis individually using the Unify switch. Since I can access the Unify console, now I can go through any of the ports in the switch and enable or disable them based on what I need, just by using my phone or my computer from my local network in my house. So as you can see, I ended up having like a really small and cool data center on my house. I'm really proud of how it works. I'm testing this on a daily basis. I have several applications running in here, and customers are actually using these applications on a daily basis. So I've been testing this for a long time on a daily basis. It works fantastically. I can get response times in less than 60 or 70 milliseconds. That's amazing considering that I'm running this on my own house, and I'm getting response times that can be compared to the response times that you get when running this on a cloud. Of course, I can keep improving this, adding new features, adding more things. I will be doing that since now I have more requirements that I need to solve using this specific cluster. So again, if there's something I can recommend is, if you have the chance, build something like this for you. It is amazing the amount of experience and the amount of hands-on experience that you get once you start working on this. I really hope that you liked the video. I really hope that you took something from it. If you like the video, if you like the content, don't forget to subscribe. If you have any questions or any comments, please let me know in the comment section. Thank you for your time. Thank you for your attention, and see you next time.